Hello to all of you who loves the Python programming language. Thank you so much for being here with me in another Python tutorial videos. Okay, and now that you understand the importance of this self, let's see how we should write this increase method. Let's define and use the increase method in Python. There are 2 points here. One is that the variables val and incur these variables must be defined from the beginning. The second point is that we cannot use the command val plus and equal incur like functions. Rather, we should write self.val plus equal self.incur. Let's go to Python. Let's have it here, for example. Let's define the class again in this video. Class count. Okay, let's have it here. Def increase. Let's consider the self keyword as its input. Let's consider annotations here too. Don't forget to put the colon. Now self.val plus equal self.incur. Okay, no, increment actually. Okay, you probably know by now that self is assigned to the current object from the interpreter's point of view. Therefore, the interpreter expects that the argument inside each method is the same self. Consider what we now know about any constructed object within a class. Different objects you create from the same class have their own unique states, even though they share methods. Now, what makes this happen? Associating the attributes values with the object. That is, you must say that the attribute you create inside this class belongs to this object. If you work in this way, any attribute you create inside this class for an object will remain special to it and will not be shared with other objects. How can this be done? Using the same self dot. We said that this self represents the same object. The point is that when you use this increase method and it ends, the val and increment, actually these variables that are inside this method will be removed from the scope and will be destroyed. That means they will end. For a better understanding, we will give an example of a function here. For example, let's have it here. Keyword def print name, for example, with out as input. Let's have in one, for example, Udemy. Into out. Print out in one in two. Okay, we now defined the print name a function. Okay, let's consider, for example, name Python. We can change the argument's name actually always, so let's call the function with this variable this time with the variable name, and you can see the result here. Python, Udemy Python. We see that interpreter put this name instead of out after run. Let's call the variable name. We can see it's Python. Now let's call the variables in one. Let's call the variable in2, and you can see that they are not defined. We see that in1 and in2 are not defined. When you define a variable inside the function suite, these variables are in scope. They work inside the function, but they are destroyed when the function is finished. In fact, these variables become extinct after the completion of the function. Now that you are familiar with this concept, you will understand what is wrong with this code. You want to store these attributes in a class and use them, but if we define them inside the increase method, excuse me, these attributes are only present inside this method. Considering that the method is the same function whose name has been changed, after the completion of its work or its task, actually, the variables inside it will become extinct and destroyed, and you can no longer work with them. The situation is different in methods. The method uses attribute values that are specific to an object. For example, consider the expression f.increase. f.increase. This f must have a series of states. It means that it should have a series of attributes such as val, incr. So these val, incr are specific to this object, and this method uses them. If we use self.val and self.incr instead of val and incr, it means that these two are supposed to be specific to the object. An object that is inside the whole class and not just inside this method. So if we use self, these attributes will not disappear with the termination of the method. This self makes the attributes survive if the method terminates. It is important to me that you understand the reason for each element in the code and not just memorize it. To understand better, consider self to mean this object's expression. As you know, this apostrophe s represents ownership. For example, self.val can be read as this object's val. Now, if you are careful, we haven't talked about initialization yet. If you run this class, create an object from it, for example, a count, okay, and then call the increase method a.increase. We will get an error that the initialization is not done. In Python, all variables need to be initialized. It depends on where this variable is. Actually, it doesn't depend on where this variable is used. Classes are no exception to this rule. For example, structured data should be assigned to these variables. Now let's see how to do this initialization. Many popular programming languages have a constructor method for this purpose. But in Python, object instantiation happens automatically by the interpreter, and you don't need to define a constructor. But there is a method inside Python called init, actually. Let's see it. You need to two underscores init and the other two underscores. You can see the color change here. which stands for initialize. These methods are called magic methods, whose main feature is the underscores before and after them. We can see the work of these, the task of these methods is to create the possibility of initialization. There are some magic methods in Python that we don't need to write in our code because they are already written. What we do is rewriting. We have said that inside Python everything is an object. A class is also an object. This class object is created inside the interpreter, and all other classes in Python inherit from this object. What does inheritance mean? Inheritance is a specialized term in object-oriented programming. This OOP is abbreviation form of object-oriented programming. We refer here to this aspect of the concept of inheritance according to the definition of inheritance. All the magic methods that are available in the class object, this class object, are also presented in your classes. These are your classes. Of course, this definition for inheritance is not perfect, but for now I accept it here so that we can talk about it in detail later. We say that our classes are children of this class object. We don't have to override these magic methods, actually these magic methods, but we can override them if we like. One of these magic methods is init. Suppose we want to compare Python expressions. This operator is by default inside a method named eq. We can override the comparison type in this magic method. For example, consider something like this. Consider dictionary containing A0, B1, C2, and another dictionary A100, for example, B200, C300. Okay. Now we can use them, we can use, for example, let's try it. What do you think? Oh, what can be? How can we use them actually? EQ, for example, dic, and anodic. Here we got an error. Dic, EQ, return self is equal to value. Actually these are used in classes. We will examine them in the examples. I just wanted to see for you to see that these are not usable in Python programming when we are not using the object-oriented mode actually. Okay. You can see some of these magical methods here. When you want to initialize the attributes inside your class, we use this magical init method. In these rewrites, we must not forget the keyword self. Let's add this initializer to our class. Def inish, actually 2. Okay, the keyword self, we try to follow annotation. Okay, pass. Now we write pass in the methods suite, but we will return to it. We want to say that these val and incur have an initial value. We typed that these val and incur are no longer specific to incurs and can be used in the whole class if they are used with self. Init is a method. Methods are the same as functions, and functions can receive any number of input arguments. So we add these arguments to the input section. We add v to initialize a val and I to initialize incur. Let's add them. V int I int. Okay. Okay. Now instead of pass, we need self dot val is equal to v self dot incur is equal to I. Okay. In this training course, we try to follow the annotations. Pay attention that these v and I have nothing to do with self and are specific to the init method. So now all that's left for us to do is to initialize v and I. Let's save the file here. For example, count class. Okay. We create the G count. Let's run it. We can create the G as a member of the class count object and get an error that init requires 2 input arguments. So count is connected to init, and if we give it input arguments, these arguments will be sent to init. Let's build h, another member of count, and consider 500 and 100 as its input arguments. Now let's call h.val. Okay, this is 500. When we say that val and incur are inside count class and h attributes, it means that we can access them in this way. So in fact, the interpreter has considered the first argument as v and the second argument as I. Let's call the increase method. So we expect val to increase by 100 units. Actually, it says that the count let's go back to the main structure of class definitions. We can here see that in class definition we need here what do you think? What is the problem here? In the increase method, maybe we need to consider well, actually these are not. Why does it problem with incur not with val? Oh, actually we forgotten are here. Okay, this was a problem. Let's run it again and do our task again. H dot val, H dot increase. Okay. So we expect the val to increase by 100 units. Let's call the H dot val here and you can see the result. Okay. If we hit H itself, it should show us H dot val, which is actually the same value, but we don't see what we expect, but this output is a coded output. We create another object, J count, the same actually. Okay, now call J. It says J is here. It is at this address. These numbers may vary. Let's apply the type function on J. It says that J is of the class of the count class. Actually, if you remember, the type function returned the class of its input object. Another built-in Python function is id. id displays information about the address of the memory where this object is stored. Let's apply the id on J. Okay. What you see when you run the same command on your system may be different from what is on my system now. Let's apply it on Ka, for example. We did not define it Now let's apply the idea on count. You can see it. We can convert this number to a hexadecimal number, which the function hex will do for you. Let's apply it. Hex on ID. Okay, what is that? Let's call the car, and you can see that these phrases are the same. You will see that you reach the last number of the address that you saw in the output. And now here it is not important to know what the hex function does and how the hexadecimal format of the numbers is calculated. Now you may ask why something like this is seen in the output. For example, if we hit J, for example, or something like this. When you don't tell the interpreter how you want to see the values, it will decide what to show you in the output. For example, here it has decided to show you the combined output of the type and the hex functions. But you can change this displayed output. How? For this, we have another magic method called wrapper. Wrapper, which stands for representation, which still exists as a built-in function. This is the built-in function. You can see the color changes here. Use the help function to find out what it does. You can apply the help function on this built-in function, and you can see that return the canonical string representation of the object for many object types, including most built-ins val, rep, object is equal to object. Okay. The task of this method is to return a string, the version of an object. Let's rewrite this here in our code. Def wrapper. Don't forget the keyword self. We consider annotations here. Actually, str. Return str, applying str on self.val, for example. We want to have the self.val in the output, but the string format of them, so we need this command. The important thing is that if you use the print function on the object, this function uses the same wrapper in its default definition inside Python. Let's here call print J, for example. You can see the same. Let's call the J itself, and you can see the results. If we write, for example, U is an object of the count class. Without arguments, we get an error. In order to prevent this from happening and to use the default value if no input is received, we add the default value like functions in the input section of the init method. We can see we here we said that we want to consider the default value of 0 for val and the default value of 1 for integer. So let's consider it. V equal to 0 and I equal to 1. Okay, now let's run it again. What is the problem here? Oh, invalid syntax. Maybe we need to add them here. Let's do that. Okay, here. Okay, you can see that there is no error. Let's apply the increase init. Now let's call u.val, and you can see this is one which is a unit of anchor plus the default value of val. Okay, in this example I explained that the key and important topics of the classes. It is better to write the rewrite of the magic methods first here, and then add the inner class methods which are the same behavior, which we done it here. We talked about two of the magical methods. Let's look at some other examples. For example, there are several ways to assign an attribute to an object. The recommended way is to use the same init, but there are other ways. In mathematical notation, the coordinates of the points are put in parentheses. You see these in mathematics actually. These are several ways to do this in Python. You can save the coordinates of the points separately. You can use tuple or list data structures, and you can also consider a separate type for saving points. It means to make the points as objects. What does this mean? When it comes to new type and a new object, our task will be to create the class. It means to create a class for points. This work is more difficult than other options and requires more work, but it also has many advantages. Let's consider. Let's do it here in Council actually. For example, class point, no need to parentheses. For example, showing a point in 2D. Okay, docstring is usually written inside the classes. The class definition is done with this first line, but we want to give a behavior to the objects we create from it. Let's have an object of this class. We can give it attribute right here in the console. Let's do it point. Let's transfer this. Let's transfer actually this here in a file. Okay, here we need something like this, and point 1.x is equal to, for example, 10, in float format, and point 1 dot y is this, for example. This syntax is similar to selecting an option inside a module, which we have seen before. This is similar to rewriting init. Of course, I emphasize again that using the magic method is better. But this one of the available way. This is one of the available ways. I want you to learn these two. Let's consider x is equal to 0.1 dot x. Okay. You can Google string formatting operations and enter the search result sites. You can see these descriptions here. You can read these parts yourself to figure out some string formatting syntax here yourself. Okay, you can read these parts yourself. But we can have here this, for example, parentheses, a percent sign, G, comma, another percent sign, G, closing parentheses, a space, a percent sign, opening parentheses, point 1 dot x, point 1 dot y. Okay. Oh, actually, I forgot to consider the ones here. Python couldn't know the object point itself because it wasn't available. Now you can see the output here. With this command line, we specify the sequences, and with this letter G, we tell the interpreter that the numbers are float type. Consider another command line, for example, a distance, define distance equal to, don't forget to import required modules. Let's import the module math. Let's define distance as math.sqrt .1.x. Remember that two star signs together represents for exponentiation operation. In power 2 plus 0.1 dot y in the same power 2 in exponentiation 2. Okay. The distance of this point from the actually origin, the point 0 and 0 in coordination, in math coordination actually, is calculated like this by this command actually. Let's call the distance, and you can see the distance here. Suppose we introduce another function, for example, def print name with the input p print the same command, and like a parenthesis, a %g, close values, yes, percent, open parenthesis, p dot x and p dot y. Actually, they can do them here. Okay, now let's call print point 1. Okay, you can see that this is similar to calling the point 1. This is the address. Okay, as an exercise, you can write a function that calculates the distance between 2 points made from the point class. Thank you so much again for watching another tutorial videos about Python programming language. Stay tuned. Lots of practical and important notes are waiting for you in upcoming lectures. Have a good day.